So it should be starting. Hello dear audience, hope you are doing fine. Let me check I can actually execute my tests, probably because after restart oh, it's IP address. Okay, after restart my IP address of my VSL box has changed, so I need to reconfigure it for running a test. So let's do it quickly. Okay, here it is. Okay, and let's see if the tests are gonna run now. What? Test. Wow. Oh yeah. I need to start my SSH daemon. Okay, now it should work. Okay, successfully connected. Now let's just start it. Okay, now I can go on and start doing stuff that I was planning to do. So today's plan to add read length encoded string and all this one is already implemented. Another one I want to implement is read null-terminated string. So here is something I wanna implement that would just read the buffer until there is a null character found in the buffer. So let's see if we can achieve this one. And then also read read of packet string is also very interesting implementation. However, I found that there could be some issues. So I was thinking about the implementation, and there can be an issue with the way how I process the buffer of the data that I receive, because right now inside of the buffer, as soon as I append the data into the packet reader, it actually appends the data as is, as it was received. So technically, in case if my null-terminated string is actually gonna be received across multiple packets, let's say I have a string longer than 16 megabytes, and yeah, I want to have a null-terminated string like that, then yeah, it's a little bit of a problem. So what I need to do, I need to implement a way to separate the actual read buffer from the packet metadata, because the payload is read in a separate functionality that uses this read fragment callable. So read fragment actually should be able to read over the length of all the packets. So it should be able to read a string across multiple packets that is more than 16 megabytes in length. So let's see. First of all, I think I need to implement this read buffer implementation that also can, for instance, scan for null inside of the string, because I don't want to I don't want to get this scan being done by reading all the data, copying it into memory, and then doing something else. So I need to add some kind of scanning possibilities for a buffer. So let's do that one first. I'm gonna create a new test case. Scans for let's call it scans for value in string starting, yeah, just for value in string. So it will be a simple case. So we just have read buffer, we're gonna append something to it, and we're gonna do something like some data. And what we're gonna check here, we're gonna check that we know, for instance, that sum and data is yeah, it's something like 1, 2, 3, 4, 5. So we expect that we need actually to we can read something up to 5 characters long in order to read this data. So I expect that they're gonna be returned 5 as a result of asking to read the data up to this character. So what I'm gonna ask for that, yeah, I'm gonna ask this read buffer to scan a buffer for this character. And here, let me just run a test. Okay, so call to undefined method. Let's implement this method right away. Here it will be a pattern, and here we'll return back an integer. It's gonna be always an integer because yeah, there are some limits in PHP actually on the size of the data, and they are within 64 bits of max assigned integer length in MySQL, so there is no issue with that. Let's go on. Let's implement something. Okay, it tells that something is missing. Why? This is always a problem. Okay, now we go into undefined property pop. What? How did I mess this up? Okay, return value of scan is not an integer. Okay, let's return 0. Okay, 0 is not expected value. Let's then return just 5. Okay, so this is a first test case that works. Then we add another one. Actually, let's rename a test to make it more descriptive. So what our test does, it tests that our scan method finds a position of this character to be returned. So scans for value. What can we do? Yeah, we can tell that scans for value in string, and scans for value. Okay, So what we will call it, we'll call it returns position of first found character, returns position, alright, actually it returns length of read in order to read data up to this character. Okay. So in this case, it will tell us that it should return 5 in order to read the data up to this character itself. So let's do it. Okay. It tells us it should be 5. Good enough. Then we can create another test case, and we will tell that it returns negative index when no match found for scan. So in this case, we will just have something like this read buffer, and we will append also some data without character. Right, or we can even do it like this, some data without character. And here actually it has double meaning. Okay, and then we assert that it will return -1 because there is no character we're looking for. So scan, and it should return -1. So now, yeah, it's obviously failing. So what I can do, I can just now replace it with just string pose of this buffer and pattern. Okay, this seems good. And let's see. Oh, actually, wait a second. Here it is, read buffer. Here we have also to add string pos into list of the functions. So we are used from the global scope. It's very important for performance because when you don't have it specified in your code, then PHP will try to resolve a function first within this namespace. And when you specify something like this, PHP already knows that this string pos function call is in global scope, not within the scope of your namespace. So it's very important for this kind of projects, because when you write something that is gonna, let's say, perform thousands of such operations per second, every nanosecond matters. Because yeah, if your string pos is gonna be resolved first in the local namespace before actually hitting the actual core function in C, yeah, it's gonna be a little bit of a problem. Okay, let's see. So we have failed asserting that 4 matches expected 5. Okay, and here what we're gonna do, actually now we have to implement a small check. So we have position, and here this we will return this position, and if this position is equal false, right, if there is no match, we return -1, and otherwise we return position +1, right? So it should be now working well. Correct. Okay, so now our test tests everything, and actually let's try actually to break it. So if okay, let's just put it like this. Will it still pass? Okay. So this is one of the cases for TDD. If something is also green, but you are unsure if it, will definitely work, you need to just replace it with this one and add more test cases in order to make your test red before you can continue. So let's add another test case, and we will test returns returns character returns length of read, even if character for search is a first one in a buffer. Okay. So then we will specify something like this. This read buffer we will append, and then we have this one, some other data. So now we have this semicolon over here, and we can create now an assertion that it should return us actually 1. So we require length of 1 in order to read the data here, and we will have a scan of this pattern, and it should return us what? It should return us 1, but it returns us -1. So in this case, we know that this one is not the right implementation. So now we can add the correct one. Yeah, so now it's green. So we're gonna go into more test cases. For now, you see we didn't test if we already read this data actually. So let's add this kind of test. So we'll add a test returns length of required read for the next character occurrence. Yeah, too much C here. Okay. Okay, let's replace the spelling. Okay, what it actually suggests, I don't see, but what is better? Oh, maybe it's actually 2. Yeah, it's 2 times R. Okay, so the next character occurrence, and now we just say that, okay, this read buffer append, then we have some other data. So first of all, yeah, we will execute this read buffer to read length of 5, so we know that this data should be read already from a buffer, and then it should return us 6 characters. So now we expect that assert equals 6 when we execute this read buffer scan for this pattern. So okay, now it returns us 5 because we actually don't move our position for a scanning. So what we can do here, we need just to specify here this current position, I think. And now we have also another thing is actually removing from this position. We need to do minus current position in order to tell about the relative position of characters to read. So now it looks like it's working, and it's very good. Another thing actually also I was thinking about that is actually missing in our buffer implementation is a standard advanced buffer functionality. So advancing a buffer is good when you just want to increment this current position without executing expensive read operation, because the read operation is very expensive because we actually substring a value, and we want to have a possibility for our functionality of the packet reader. For instance, when we go through the interface here, you see here there's this next packet function, and I want to make sure that when I invoke next packet and there is some unread data, I can just advance a buffer to that to the rest of the packet position. Okay, so let's actually implement this one. Let's also make this functionality working. Let's say it advances buffer position for the next read, or just it advances the buffer position. Good enough, I think. This read buffer, we will append some very long data, and then we will put here this read buffer advance. So how many characters I want to advance? I want to advance it by 10 characters. And then here I'm gonna assert that reading another 9 characters should result in this long data. So long data should be returned when I will try to read 9 characters. So in such a way I test that, yeah, I actually advanced my buffer by 10 characters. Okay, advance is not method. What it will be actually void, because we don't want to return anything from this method. It's just a comment method, not a query. So here we're gonna just advance by length, I think. Here, so let's use the same argument name as in read, and here yeah, our test is failing because it doesn't advance anything. You see it returns us some vary instead of long data. So what I will do here, I will just do something like this: current position plus length. Also, what if the length I'm trying to advance the buffer to, what if the length is actually yeah, not available, right? We need somehow to prevent to advance this one. Or actually, wait a second, I think I just can do something like this. Okay, I don't have yet enough test cases for advanced variations, so Let's call this one from beginning. Of buffer, and here advances buffer position after read. Okay, and here we're just gonna check this read buffer. We will append some other nice data after advance, and here we expect that this one we will read this data first, so this read buffer read 10, then so this 10 are read, then we want to advance by 11, and we want to receive, actually, yeah, so this is 11, we want to receive this one, it's 13 characters, so we're gonna assert that the result of reading 13 characters from a buffer is gonna be after advance, and we see that, yeah, our advance method is broken, so we need to fix it actually to do a proper variation of the test. So this is all about making sure that you have an adequate code coverage. And as you see in my case, there is more tests than lines of code in this method. Why it's important? It's important if I get to change this code after a very bad sleepless night, and I will do some stupid mistake here, my tests will show me that I did a mistake. Because if I wouldn't have this read after actually read advance read test case, I wouldn't be able to catch this problem with current position being not preserved for this advanced operation. So it's good just to have those test cases in, and it will come with experience for majority of developers just to write more tests than actually lines of code you have. So let's go on into further implementation. Let's see. I have advance, I have scan. What also I want to have when we're gonna re-implement the functionality of appending only the data that is part of the payload, I also want to access what is the current position in the buffer. So I want to make sure that I can do calculations also in my packet reader to know how much bytes left in a packet before and yeah, comparing to the length of the packet, how much I actually read so far. Because here in a read buffer we have actually not a read buffer, sorry, in string packet reader. Here we have this method called read rest of packet string, and for this one we need actually to know what is our current position in the buffer before we flashed the buffer, because here when we read the fragment, only in this case we reduce our current packet length, but also there is sometimes a reader can request this end of a buffer and we are unsure where this length is. So without changing this packet length, it's gonna be a little bit complicated to implement. So let's do that. Let's implement this current position in a buffer. So how shall I call it? Probably the good option in this case is to call it maybe position. Maybe it's just enough. Or call it current position. Yeah, I think current position is better. So public function, oh yeah, I have a nice template. So spec returns current red position in buffer. Oh, actually, default red position in buffer is 0. So in the first generative test case, we'll just assert equals 0 this red buffer current. Let's call it actually offset or position. Offset or position, what is better? How do you think? I think maybe it is position or length. I think current position is the best one because we also have the same property internally, so it's kind of reasonable to call it just current position. So the default current position is this one, and what will return here will just return 0. So for now, yeah, first of all, it's integer. But current position is actually gonna be a little bit different in the end, and you will see why. So then we have this test is actually passing. Let's just make sure it's actually failing. -1. Yeah, it's failing. So now let's hard code this one. Now reports current current position is moved with a number of red bytes. So let's add this one, this assert equals. Let's say we're gonna read something like 10 bytes. So let's just do assert that it's gonna be equal to 10 bytes, and then we're gonna actually implement this red buffer, read a length of 4, and we actually then also gonna read a length of 6. So in total there will be a 10, and here we're gonna actually append some data because otherwise our read operation will never succeed. So we'll append some very long string data. Okay, here we have yeah, so now I think it's good, right? Fails rings at 0, matches expected 10. Okay, so now we can just tell that yeah, the current position is number of bytes read. Good, looks good. So this current position, and then also I want to add a test case that current position is relative to flashed red data. So in this case, we're gonna again use the same data itself. So we read, let's say 10, and then we will call this flash, and yeah, so here it's going to be a 10, then we call flash, and then this red buffer read, let's say 3 characters, and here we will tell that it should validate that the current position is equal to 3, because since last flash I read only 3 characters, not 13. Okay, so now it tells me it's 13, so I need to adjust this one and replace it with current position minus this red position. So it should give us now relative position, and everything looks pretty good. What else do we have? Oh, actually we didn't implement an error in case of the advance. So if I try to advance more than size of the buffer, it should report us that the buffer is incomplete. So reports incomplete buffer when position is reports incomplete buffer when advance is larger than current data. So let's do this one, this read buffer append, and we will put here some data, and we know that this some data is, let's say 11 characters. So first of all we are gonna execute this read of how many characters. For instance, we will read 5 characters, and then we will just try to advance by 5. So we cannot advance by 5 because there is not enough data. So in this case we expect that this expects an exception, incomplete buffer exception class. Okay, it's not throwing an exception. So what we need to do, we need to I think we can just add a check like this. And we just need to throw new incomplete buffer exception, right? Okay, now it's good enough. What we can do further on, I think we can refactor a little bit. Oh, actually we have already very nice ways to optimize this one. So now here we have the possibility to use the current position. Let's actually rename this property. Actually, let's rename two of those ones. Let's rename this one into wait a second. Let's rename it into red buffer offset, and here is gonna be also current buffer offset. Okay, at least now we don't have confusing variable names, so we have number of bytes read is a return value from position. Then we have if read buffer offset is more than equals buffer size. And then we do this operation of resetting all the positions. The other things I think is quite good. Yeah, we can just go on and start now implementing this packet reader. What should be implemented here is actually we need to create this null-terminated string reader. So reads multiple null-terminated strings. Okay, now we will have our payload. So here we'll just for now set a default 0 size packet, and let's put our data. So first of all, we're gonna say first string, then we're gonna terminate it by x00, then second string is gonna be terminated by x000, and then third string is gonna be terminated by x000. Okay, seems like good expectation, and let's see how much characters it is. Yeah, it's so pity PHP-Storm doesn't actually count these characters like this. So it's 12, 13, and 12. So 24 plus 13 is 37. So 37 plus 12 is 49. So it should be 49. And let's see. Deck hack 49. Let's see what's it's gonna be. Oh, okay, let's show. It's gonna be 3.1. So okay, so the length of the packet is 3.1. Oh, I changed the wrong test, so it should be 3.1 here. And here we're gonna invoke this read fragment. What I was thinking, actually, maybe it just makes sense to to extract this read fragment operation into more reasonable one. Okay, so here we will have read length encoded string or null. Yeah, so what we can do, we can actually create a private method that will invoke read fragment with some data being returned back, so we don't have to do it all the time in our tests. It's actually going to be a very good improvement for our test readability. So we'll call it read fragment. For now, actually, let's just this mark test skipped. Read fragment. It will return back what, an array of the data, right? And as an argument, it will have a callable. Okay. We'll call it fragment reader, and then reader will receive this read fragment. Then we have our function fragment. It's packet fragment reader. Fragment reader use this data, right? And here we're gonna just assign actually this data as a result of this fragment reader. Oh, sorry, this, yeah, fragment callable. And here we will also pass it as within the scope of this method. So fragment callable will be invoked with the fragment reader. And then we will return back the data. So it's going to be a little bit better. So for now, all the tests are passing. So what we do next, we actually start to replace test by test. So I will say that this read fragment, and then I replace it with this one. And here I'm gonna just return back an array of read fragments. And now let's see. Now our test still passing. So yeah, this one I like more. I don't need anymore this data. And yeah, now it looks cleaner in my opinion, because it's just cleaner. Okay, so let's replace here as well. I like this test now. Yeah, still green. Let's see. Yeah, here we don't need to. Actually, here we can also replace it. So, but here we actually can return directly a null, right? And here we just can this assert equals. Like this, right? Assert it equals actually null. Okay, let's remove this array notation. We'll just actually how do I just define it? Can I just use something like this? It's not breaking, right? Oh, cool. So if I want to pass something, I actually don't need to define this variable in advance, because here it gets assigned and then I just return it. Nice. I didn't know in PHP it's possible, but it's cool. Okay, now let's see. So we expect it's gonna be null. It's null, and let's replace other places as well. Yeah, here it still should be okay. Okay, here we have a big one to replace. Okay. And here yeah, we need to replace these ones with colons. Colons we need to replace with just commas. Okay, now it's done. And here it's done, I think, too. Okay, the test is still passing, right? So it's good. And here as well, another candidate for replacement. So I'll like this, and like this. It should be 8 bytes long. Still green, good. This one doesn't use data. This one doesn't use data too. This is doesn't. Okay, so here is. The result is. Oh, here is actually. We'll leave it like this. Okay. Actually, I think like we don't need to have this call here in this test, because this is a basic idea why I actually want to replace the packet from an actual reader. So let's see, do I have any other checks? Okay, if it's a full packet, true. Yeah, because why would I need to call next packet if I already know that I reached the end? I just want to read the next value. But now we see that this one actually is not working, because, yeah, as expected, because the append is not thinking about reading multiple packets. Yeah, so here is the problem, because first of all I added to the read buffer, and now we're gonna do something like this. We're gonna actually split our read buffer by packets in order to implement this functionality. So I want just to go over multiple packets at the same time, but yeah, let's actually do it a little bit later. Let's just return back this one. Oh no, I want to have this one removed. Okay, so it's still passing. Read buffer works, packet reader test works, reads multiple null-terminated string. So first we need to implement this one. So I'm gonna implement this data, this reader. Oh, actually, data should be equal to this read fragment, this new and nice method. And here is packet frame reader, fragment reader. Actually, I think it's even better to rename it, because it's actually not a fragment, it's actually a payload. So probably we'll just rename this interface into packet payload. Good. So now it reflects actual terminology of MySQL. And here actually what we're gonna do, we're gonna also rename this one into read payload. And do we still have everything passing? Yeah, except the new test we write. And here we're also gonna rename it into read payload. Let's see. Executes callable to read a packet payload by using payload reader. In case of incomplete buffer exception is thrown during reading, method returns false and same data will be returned to the next read. The code of reader must not catch this exception. Okay, so this is good. Yeah, now I like it more. It's more descriptive because fragment was a little bit not good for this functionality. Okay, so here actually also this packet reader is something different. It's not a string packet reader, it's uncompressed packet reader. It's actually the implementation that I know is correct. And this one is gonna return uncompressed packet reader. Okay, it's good. So we specify that this packet reader is actually a one that is reading uncompressed packets from MySQL connection. So this is good. Now we need actually to implement this null-terminated string reader. Yeah, let's go back to our test. And here in read payload, we're gonna return back fragment reader read null-terminated string. Fragment reader read null-terminated string. How many of them we have? 1, 2, 3. Read null-terminated string. So 3 terminated strings, null-terminated strings should be read. And what's the result of this read operation should be? It should be first string, then it should be second string, and then it should be third string, right? Return value is not correct. It must be type of string but non-returned. So let's just return here, return an empty string. Okay, let's see. Okay, packet reader. First string, second string, third string. Okay. This one is clear. Now let's implement it, I think. Let's implement just a successful case. So first of all, we're just gonna do this read buffer. We're gonna scan it for null character. Right, and what we're gonna return, we're just gonna use this read, this amount of bytes, and we're just gonna return it. Let's see if it's gonna make our test green. No, because it's a binary string, and probably because the null character is returned. So we actually need to read till the character. So string is gonna be read till the character, and then we actually need to implement this read buffer advance by 1. And we need to return back this string. Okay, good. Actually, it's working. And it's working actually very well. But what if I just comment out this advance? Yeah, it's just gonna return us wrong data. Looks good. You might ask why actually I just don't read it together with the null character and then just stream this null character. First of all, because I don't want to copy a string that was already read. I just want to read it and then just move it by 1 character, because I know that null character is 1 length. So let's go on. Let's go on with the implementation. Let's add another test case. And another test case is gonna be stops reading payload when a null character is not found for a string to terminate on, right? So then we just assert that actually what we can do is actually implement something like this. So we expect that this one is never actually returned. So we just know that this one is never gonna be returned, so we know that there's nothing gonna be read, so there should be thrown an exception that should be catched by a reader. So let's see, this assert stops reading payload when null character is not found in the string. So let's see that expected result is what? Null for the data. Okay. Somehow it actually returns me some data that is actually wrong behavior. Read scan -1, yeah, because this one doesn't check if it actually found anything. So what we will do here, null position, if null position is equals -1, what we do here, actually here is we just return back we return back actually we throw an exception, throw new incomplete buffer exception. So it actually should stop execution of the buffer reading. Okay, so now it actually worked. So let's see our packet reader test. So okay, it expects that the data is null. It's correct. And also let's add another test case. Reports in complete payload read when null terminated string is not completely read. Okay. And here we actually wanna validate this one, this reader, read payload. In this case, we assert that this read payload returns as false. So false. Okay, seems like a good thing. So it's done. And then let's create another test case. Let's see if we can break this functionality. Let's, instead of, let's say, null position, we just return null. What will happen in this case? Yeah. Okay, so we know that if we don't throw an exception, then it will be broken. So good, our test covers us here. Now let's go into the next stage and let's implement read end of packet string. So spec reads string that represents complete packet. So let's do it like this. This reader append 00x. Actually, how long the string is going to be? Let's make it 10. So let's be a. Then it's going to be, oh yeah, it should be double quotes, not single quotes. So 0a, then x00, 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 and then gonna be our string, and the string gonna be, this is, how long it is already? 8. Let's call it, this is 10. So good, exactly 10 characters, and looks pretty good. And also let's add another packet in the end of 0 length. Okay. And here we're just gonna assert equals. This is 10. When we try to this read payload function, payload read rest of packet string. So we expect that this is 10 is going to be returned for us. Okay, it's not returned, so let's return some empty string. Yeah, it's failing. So let's just do this read buffer, read a length of how long of this current packet length. Okay, good. Now it's green. And now I also want to implement another test case for this one. Reads spec reads a string that presents remainder of the packet. So still we're gonna use this as 10. The only thing, yeah, before it we're gonna read some data as well. So this is 10. Now it's gonna be let's say B, C. Yeah, let's add here some binary data like 01, 02. So we make sure like we read first this two 1 byte integers. So read fixed, actually read fixed integer 1 byte and another 1 byte. So we read two integers and then we read the rest of the string, but we see that incorrect data is returned back to us. So what can we do here? We can actually go and implement it correctly, because you remember that's why we've created this read buffer, current position. And looks like the current packet length, yeah, because the current packet length is incorrect, I think. Yeah, what did I specify here? 0C, and in the end I read like 2 bytes. Okay, let's see. Let's see what actually is the current length here. Let's debug it. So the current packet length in this case is 10. And this is the first test. Let's see the second one. The second one is 12. And what is the current position of the buffer? Current buffer offset is 6. Oh yeah, this is it. It is because we have this implementation with initialization of the packet itself. So when we switch a packet, we have actually to flash the position in order to properly identify that we are already reached a limit. So let's go here into the reader implementation, and let's go here into init packet, and here we need to implement this read buffer flush, I think, right? Just to make our test pass. Okay, so this test is green. Now our packet reader is a complete implementation that can read all the required data for a payload. The only thing I don't like here is that here, when we read multiple packets, yeah, we just move forward here. Okay, let's see what we can do here. Let's see. Okay. Here I think it's quite well. Now let's implement this new packet reader implementation that actually automatically goes into the next packet. So let's remove this next packet call. And what I actually wanted to implement, yeah, so first of all, allows to read multiple packets of integers. And here I just gonna say that, okay, here I'm gonna implement this append functionality in a little bit different way. So first of all, I'm gonna extract here register packet, and we're gonna implement this method like this, and we're gonna put here a new method. And let's say if not set this current packet length, then what we will do here, we will probably I'm just gonna improve this test a little bit more. Where is it? Let's also put 5, 3, 4. Two, 4, 3, 2, 4, 4. And here in our uncompressed packet reader, yeah, we have this register packet method that returns what string it will have something like this. So argument 1 passed to MySQL binary protocol read buffer is readable, must be of what? Must be of where is it? Sorry, here it is. Must be of type integer, null given called in. Okay. Register packet. Here I'm gonna add a logic for extracting the packet length. So we will have another variable here. We'll call it packets. It's gonna be a registry of packets that is gonna look like this. It will look like each packet is gonna have length of packet, sequence, currently accumulated data, and there will be multiple registry like this. So what it gonna help us with, it's gonna help us with controlling these variables. Okay. And then we actually will not need this current packet length and current packet sequence. So here it's going to be a length of a packet and currently read data as well. Probably going to be to part of this, or actually not much. We're just gonna take the current packet length. We're gonna take it from length of the packet minus the flashed data itself. Okay, so here we will gonna register a packet. So if no this packets, there's no packets, then we gonna take, let's say, a data of, yeah, we're gonna accumulate some data here. So what we're gonna accumulate, we're gonna add a new packet first of all. We're gonna specify this binary integer reader read fixed from this data. We're gonna read a size of free int, and then we're gonna read this binary integer reader read fixed, and then it's gonna be data actually 3, and it's gonna be read with the size of 1. So this is gonna be sequence, and here is gonna be packet length. Okay, so this is what we have, and here the data is gonna be substring data mine from this 4 bytes. So we're gonna remove the data size here like that. Okay, argument 1 pass 2 must be type of integer. Okay, no given. Yeah, so it's good. Then we will set this current packet length to these packets. Actually, to current. Actually, yeah, it's gonna be packets 0. Oh, yeah, I just can actually do something like this: list current packet length, and this current. I actually don't need current packet sequence, so yeah, the current packet length is actually this packets 0, 0. Okay, so all the rest of the tests are actually working. Okay, it looks good. Here, what I wanted to do, I wanted to be able to read multiple packets, right? So the multiple packets require something more. Yeah, let's see. How can I do it? So here we have binary integer reader. We read fixed this data. Yeah, it's good. Actually, what we can do, we can just say that packet meta is substring of data from 0 to 4, right? Data equals substring of data from 4 and further on. Okay. So the current packet length is this one, and now we can just say packet meta and packet meta 3. Yeah, so we have it. And here we have now our tests again passing, so everything is good. The only thing that we need now to iterate over multiple packets. So this one can be called actually register a packet from a data. If, for instance, string len of data is more than so this is actually the first one. If string len of data is, let's say, bigger than this current packet length, or here's actually we need somehow to check how big is the packet, and we need to split it up into valuable information. So we just need to add more of the packets to this array as soon as we iterate over it. So yeah, it's a little bit complicated. We have to somehow keep a registry of how many data we read. So I'm actually gonna create a variable like this, private awaited packet length. So it's gonna be an integer of int 0, and it's actually gonna be 0 by default. And here it's actually gonna be if oh, I see, very nice pattern I can use here. Okay, so awaited packet length. Okay, here is it. And now here I can actually use if awaited packet length, if let's say string len of awaited packet length is more than, oh, actually, if string awaited packet length is actually less than string len of the data, then what we do, we just execute this buff, this so we find the packet meta of this awaited packet length right from the data, and the data will be from zero till this packet length plus substring of data from this from which size, actually from this awaited packet length plus 4, right? So we skip the packet method and we just add a new packet information here. Okay, looks good. Good. And next, what's gonna happen is we're gonna also register if yeah, so let's fix also now the test for current packet. Yeah, so we will not use this init packet method anymore, and is full packet. We just check packets 0, 0, actually 3, right? So it should be the remaining buffer, and here actually we need to add this one, so this string len of data, right? In the current packet. Oh, sorry. So here it's actually something for the full packet metadata. So we have a data here that's gonna be returned back, and it just tells that there is a next packet going on. Right, but it means that this packet's current. Yeah, let's just check. From the packets we have the last item, so we have this packets count, this packets -1, so the last one, the third option will have plus this awaited packet length. Actually, here is buffer data. It's gonna be something that we return back. Here the buffer data will contain an addition of the substring of the packet from yeah, it's a little bit complicated. I think I have to start from scratch here. Yeah, let's start from scratch here. So first of all, let's just check if we have some kind of current packet data, this awaited packet length. So awaited packet length is gonna be equal to so packet meta is gonna be a substring of data 0 to 4, and then data gonna be equal substring data 4, right? And the awaited packet length is gonna be this binary integer reader, read fixed how much 3 bytes from packet meta. Oh yeah, the other way around. Packet meta, that's we read actually 3 bytes, and then we add to the packets, we add in information like this. We're gonna have packets, and we're gonna add here this awaited packet length. Then it's gonna be this binary read integer read fixed of packet meta 1 of size 1, or actually packet meta 3, right? So now we have a packet here, good. And then also again this awaited packet length and we should decide the minimum out of the awaited packet length and string len of the data. So this is currently oh, actually just should be a packet length, so this the value that is read, and here is something. Oh, it's actually just the value of the read packet. We actually don't need anything else there, so I probably, yeah, so it's gonna be currently read length. Oh yeah, remaining to read length. So this is going to be our packet information meta. And this is going to be the packets 3. Okay. So okay, we have a current packet here, we have this one here, okay, and defined offset 3. Okay, it's clear because it shouldn't be offset 3, it should be offset 2. So allows reports complete packet available even after fragment is read. Okay, why? Oh, okay, because I don't deduct this value, so I need to deduct the current packet lengths like this. Okay, this seems good. What is still not implemented? Read string that represents complete packet. Okay, this one is broken. Oh, so our... Oh, no, multiple is still not read correctly. At least it kind of works. Less than string one of the data. Okay, if for now it's if this is 10, and what else is broken? So for now it's only this one. Rest of the string packet, yeah, understandable, because I don't use the correct value here. I need to use packet 03. Oh, 02. And we actually better to move this method outside as a method that will return us remaining packet length to read. Okay, so here yeah, it's crazy. We'll call it private function advanced packet length, I think, int read length. So this is gonna move our packet away. It's actually not gonna return anything, I think. Yeah. So we're just gonna advance the packet length by the size of the flash. Oh, wow. It's already working. Wow, that's cool. But why it's working? why it's working. Okay, let's, if it's green, we just need to create a new test. Reads multiple packet of full packet strings. So let's just validate that this part works well. This reader append so it's gonna be C. Now it's gonna be a length of this time 5. Or actually, let's do it like this. So first is gonna be 3. So the packet length of the 3 characters. It's gonna be a packet 1. Oh, I know why it's working, because I was actually appending separately, right? So it worked pretty well. Yeah, that's why it's working well. Now it's clear. Reads multiple packets of full packet strings added as a single network packet. So now we're gonna have some fun. We're gonna add let's say another packet of 3 that will be 2, and then we're gonna add another packet of 5. Right, so the packet of 5 is gonna be the packet of 3. The third packet, it's gonna be the packet of the length 4, and let's just, for the sake of sanity, add the packet of 5 that's gonna be again 4. Oh, the packet of 3 is actually the length of 5. Yeah, so now it's gonna be a single one, and here we're gonna implement this reader. It will just process those packets. Okay, so append we have 1, 2, and 3. So now I expect that it's gonna be assert equals of an array of 1, of 2, of 3, and of, oh, actually let's make it 4, not 5, because it will be a little bit complicated to read. To see packets out of order, so yeah, let's see, 1, 2, 3, and 4. And now what we're gonna do, we're gonna just invoke this read payload function, and here we're gonna return back this read rest of packet string 1. This, oh, not this, it's gonna be a payload reader, and it's gonna be a payload reader in which we are gonna invoke this read rest of packet string 3, right? Okay. Fail asserting the two arrays are equal. Okay, it's good. So 1, 2, and 3. So 2, 3, and 4 are actually not reported. So let's add that one here. And now in our append method, we have this register packet method. So here, first of all, we're gonna add something like while we'll call it data to parse. So data to parse will be like this, and the data itself is going to be just an empty string. So awaited packet length. So while we have actually some data to parse, if string length of data to parse, let's say more than this awaited packet length, then this data we're just gonna substring data to parse with 0 till this awaited packet length. So we're just gonna add this one to the data. So we finish the previous packet, and we set this this awaited packet length. Oh yeah, and that data to parse is gonna be reduced by data to parse from this awaited packet length 0. Oh yeah, so we start from the next data length, and in this case we also actually do what? We also set this awaited packet length to 0. Oh, or actually, in this case, it just means that we have more data, and here we'll have a data to parse of the packet meta like this, and then again we're gonna substring this data to parse starting from the 4 characters. And this awaited packet length gonna be equal to oh yeah, so here is actually what's gonna happen in this case. Okay. Looks reasonable. And oh, what did happen? What did happen with my code base? Why it's restarted? It's crazy. What's up with my computer? This is a little bit interesting. Somehow my VSL got restarted or what? IP address 49. Oh my goodness. It just changed the IP address of the container. Okay, cool. Did my test actually kill a VSL by accident? Okay, I see. Yeah, because I have an infinite loop, and probably that actually killed my VSL container. Yeah, nice. Okay. Then data to parse is more than this one. Then we set data like this, and we set data to parse to this value of substring of the data, data to parse from, yeah, I've lost all the progress because of the container being restarted. It's crazy. So data to parse, it equals substring data to parse to what was there? It's crazy. So here we're definitely gonna continue, or actually I'm just gonna have something like data to parse gonna equal what? Gonna equal to yeah, so start till this awaited packet. Also, it should be actually awaited packet length from 0 till awaited packet length, and it should be accumulated. Then there should be a data to parse, and then we should have something like this awaited packet length, till which length? Till actually the end. Then here no. Okay guys, I have to end the stream because it just kills my container somehow. Something is wrong with Windows, probably I have to restart the system. Okay. Thanks everyone for joining the stream, and till the next stream.